Hello, welcome to the Maya Toolbelt. This is Michael. In a recent video, I demonstrated a little bit on how to use aim constraints. So I thought the next video that we did would go over how to constrain with the aim constraint in more detail. And that can be found in the animation menu set, constrain. We have lots of different types of constraints. And we'll talk about aim. And we'll go in the options here, and we have these settings that we'll get to one by one. So the main thing that aim does, if you haven't seen the demo video I did earlier, is it aims one object at another. So to demonstrate this, let's just create a sphere. And to have something aim at it, how about a camera? So let's go to Create Cameras, and I'll just do a standard camera here. I'll go into the options and make sure they're all reset. Reset settings, hit Create. So now I have a new camera in my scene, and I'm going to have it aim at the sphere. I'll just kind of move it over here. So the first step is to apply the aim constraint. And I'm going to go into the options here and edit reset settings. So I have my default constraint settings. So the first object you select is the object being aimed at. Hold shift, and which is the sphere. So hold shift and then select the object being aimed, which is the camera. So I'm going to go with those two selections. So I'll go to constrain aim. So you'll see when I move my sphere now, the camera is rotating. However, the camera is not looking at the sphere, if you can see that. It's actually looking off to the side. And we'll get into why in a second. But if I move the camera, the rotation of the camera will change to try to look at the sphere. You can see it how it's spinning around the sphere with me just moving it. All the rotation values you see are kind of highlighted in blue, meaning that they are being controlled by another factor, being in this case being the aim constraint. But the camera is not looking at the sphere, it's kind of facing the side of the camera constantly, and we want to fix that. So let's go into the attributes, and the attributes, hit Control A, and we have our camera 1 aim constraint. I'm going to transform attributes, so don't worry about that right now, we'll close that, and aim constraint attributes. And we have most of the same settings here as we do in the aim options. If I put them side by side, you see I have a couple different things that lock output as opposed to maintain offset. That's a different one. Then you have offset, aim vector, up vector, world up type, world up vector, world up object. All those are all the same. And then one of the differences is over here in the attribute editor we have constraint rotate and constraint vector values, and these are all highlighted in blue, meaning they're being controlled. And then we have a rest rotate position and a checkbox for enable rest position. And over here back in the options, things that are not in the attribute editor, we have animation layer, which we're not actually going to get into in this video. It's kind of a topic all on its own, but you can have layers of animation in your scene and apply different animations to those layers. And this is, if we had an animation layer, which we don't because it says none here, we could apply the constraint of the camera to a particular layer if we had one. And then set layer to override. Again, that's more of an animation layer thing we won't get into. Then we have constraint axes. By default it's all, or you can choose X, Y, and Z. Again, we'll go into these. And then the weight right now is 1. So some of these things are not in the attribute editor, and we'll come back to those. But this is the aim constraint that we currently have active. So the first thing we'll look at, I'm going to skip offset and such, and look at the aim vector. This is the most important thing for a basic aim constraint, is the aim vector. And these three boxes represent X, Y, and Z. And by default, when you apply an aim, the aim vector is X, 1, and 1 being on, or completely on. You can have different degrees of vectors. If you wanted something to be aimed at kind of a diagonal from the aimed object, you can do that. But just to keep things a little bit simple at first here, before we get into all the complexities, aim vector X1, so you'll see the camera's X-axis is this red arrow. That is what's pointing at the sphere. So whenever I move the camera's local X-axis is always pointing at the sphere. And so you can change this here, and we actually want the camera's negative Z-axis. See, the positive Z is where the arrow is pointing, and the front of the camera is going the opposite direction. So we want a negative Z-axis to be the direction that the camera points at the sphere. So for the aim vector, we'll change the X input to 0 and change the Z input, which X, Y, Z, to -1. So we say -1 because, again, we want the camera's facing the negative Z-axis in its local space. So -1, enter. And now the camera is facing the sphere. So whenever I go to Panels, Perspective, and Camera Shape 1, that's the new camera I made, you'll see now I'm looking at the sphere. And if I try to move my camera, you'll see it kind of is fighting with me a little bit because it wants to keep looking at that sphere. If I select the sphere and move it, you can see how my camera will constantly be looking at it without me having to rotate the camera. I'm not controlling the camera at all. I'm simply moving the sphere while looking through the camera, and the camera is rotating to look at the sphere no matter where I put it. So you could, for example, have an animation of a car or something kind of driving down the street and have the camera constantly looking at it without you having to necessarily animate the camera. And that's aim constraint in a nutshell. That's literally how you get something to aim at something else. The basics being it's just selecting them in the right order and then applying the correct aim vector. And obviously there's lots of other things here that we're going to get into next. So let's look at those things now. And because we have an aim constraint active in the scene, it'd be easiest just to kind of modify the attribute editor and see how the camera reacts whenever we make those changes. So back up to the top, we have lock output. If I close the attribute editor and see my rotate X, Y, and Z are highlighted blue, indicating they're being driven by a driver object or a constrained object, which is the sphere. If I move the sphere, the camera rotates. If I try and put in a different value for these, if I change rotate Z, you see I can do it. So I've moved it, so it's rotating down. Select the sphere again and move it. You see it pops back to looking at the sphere again because they are constrained. But they're not necessarily locked. I can still rotate them around and it will react to my commands. If we lock output, check that box and go back here and try to rotate this stuff or input values, I no longer can. It just is locking these attributes, locking these output attributes, the output being the ones highlighted in blue, so that I cannot change them anymore. I have to use the sphere to change those values. That's what lock output does. So that can be a good thing to have on if you don't want to accidentally bump your constrained channels. So that's lock output. So the next attribute that we're looking at is offset. And what this simply does, it allows you to offset the constraint from the target. Right now the camera is looking directly at the sphere's pivot point. But if we wanted the camera to look at the sphere but kind of to the side, or not directly at the sphere but around the sphere, you can adjust that with the offset values. So again, these boxes are X, Y, and Z. Let me show you one little trick with these input boxes. If you hold Control, click, and drag in one of these boxes, you can actually use it as a slider. So right now I'm kind of sliding this value left and right, and you can look over to the left, you can see my camera pivoting on the X-axis. So it's looking toward the bottom of the sphere or looking more toward the top of the sphere. When you put it back to 0, it'll look at the middle of the sphere. So the offset value controls the aim vector looking slightly away from the target. You can offset the aim. Then the aim vector we've talked about is what axis of the aiming object do you want the aim to be on. In this case, we're using the -z for the camera, so the camera is looking at the sphere. You can have more than one of these active at a time. So right now, we chose -1 because we're using this camera looking directly at the sphere. But if I did -1 in the Z, but also did, say, +1 in the X, so now the camera is kind of looking diagonally away from the target. So again, that's another way of kind of offsetting from the target if you needed to. And you can animate all this stuff as well. And again, I have the trick of Control left click and drag to change these vectors like a slider. So that's one easy way to kind of see what each of these things can do. But since it is a camera, it makes more sense for it to be -1 in the z-axis pointing at the sphere. So then the up vector. The up vector is you're determining which direction for the object is up. And by default it is the y-axis, which Maya is a y-up application, which can be edited. You can make it have a different axis be up if you need to. Because for example, other applications might have z as up. And if you're trying to work together with those two applications, you may need to change Maya to have a z up as well so that they will comply together. But for the most part, y up is usually what you want. But you can set it so that the up vector, you can set it so that the up vector is a different direction. If we were to say up was x and not y, now my camera is kind of on the side because it thinks the x-axis is up. And whenever we move the sphere, it will try to maintain that vector so that x is always pointing up. But we'll move it back to y because that makes the most sense with the context that we're working with. And you can put more values in any of these input boxes to change that to be more of a diagonal if you wanted to. So next we have world up type and world up vector. So the world up type is vector, so it's using the world up vector value to get that attribute. And the world up is simply direction is up in the entire scene. So up vector controls which direction is up for the object, in this case the camera. World up vector controls which direction is up for the entire scene. And you can change this world up type to be a different value. Vector is the default. If we chose none, you'll see that my camera shifted now to the side because it doesn't know which direction the world is up, and it kind of confuses it. That's typically not a good idea to have none as a world up vector, world up type I should say. With vector, you're telling it that these XYZ coordinates found here in the world up vector section, this is the world up value, and you can use that. Then we have object up or scene up and object rotation up. To use scene up as a world up type, it's actually using what you have set in the preferences of Maya as to what the world up vector is, as opposed to setting it yourself. So in window settings preferences, you can control in here under the settings section what the up axis is, and right now it's Y. So by using world up type, using the scene up setting, we're using this value here. Or if you use vector, you can set it yourself. And then using object up, it actually means it will use the up of a specific object. You could use the sphere, for example. And here it's asking for world up object, and you type in the name of the object you wish to use as the basis for the world up type. or the world up vector. So this sphere is named P sphere 1. If I type in P sphere 1, enter, then the camera will use the P sphere 1 object's up axis as its world up vector. A little confusing, but essentially you're using a different object, a certain object's up value. If you don't want to use the scene for some reason, and you want to use, if you have an object over here to the left that's oriented the way you want it to be, you can use that object as the basis for the camera's up axis. Alright, next we have object rotation up. So like object up, object rotation up uses another object as the basis for what direction is up. For object up, what it's doing is it's taking another object and using that object's orientation to determine which way is up based on its world space, like where it is in the world. Object rotation up means you're taking another object and whatever its local up value is, you're using that, which can be different from the object's world space. So you have world space, which is the scene, and then you have object space. So if the object is in the world but rotated, and it uses object up, that object's rotation compared to the world, then you have the object rotation up, meaning you're using that object's local up axis no matter where it is oriented and using that as up. So that's the difference between the two in a nutshell. For the most part, I recommend just sticking with vector, telling it world up is Y. For the most part, 99.9% of the time, that'll be all you need to do. So then we have the constraint rotate and constraint vector values here that are highlighted in blue. These are strictly for your information. They're just showing you what these values are. If you ever need to know what the rotation or the vector is for the object at any time, here's the information for you. So next we have rest position. We have enable rest position on or off, and then rest rotate position values X, Y, Z. So what this means is that if the constraint is turned off, the camera will choose to move to the rest position. If the rest position is not active and the camera is turned off, the camera will stay where it is. So let me demonstrate. So let's change this rest rotate position to something that's easily identified as 0, 0, 0. Okay, so close the attribute editor, select my camera here, and over here in the channel box you'll see I have ball W0 with a value of 1, ball being the sphere. This is the weight. If you recall back in the constrain aim options, we had this weight slider, the default value being 1. This is where you change that after you've applied the constraint. So the weight is 1. If I change this weight to 0, I'm turning the constraint off. I'm making the weight of the constraint 0, meaning no weight at all, meaning the constraint does not have any effect. So 0, enter, you'll see my camera rotates around, and you'll see over here in the rotate XYZ 0, 0, 0. It's rotated to that rest position when the weight is 0. Let me undo that, go back to the attributes, uncheck enable rest position, close the attributes, change my weight to 0 now, and watch the camera. When I do that, it doesn't move. It just stays wherever it was when it was turned off. Let me turn it back on and move the sphere over here. Turn it back off. Camera stays there now. And I move the sphere and the camera doesn't move. If I change the weight to 1 now, the camera will flip around to look at the sphere again. So rest state or rest position just simply indicates where you want that camera to rotate to if it's not constrained to the sphere or not constrained to anything else. If that constraint turns off, the camera will rotate to a rest position if this is checked. If it's not checked, it'll just stay where it is. Okay, hopefully that's self-explanatory. Before we go too much further, it is possible to constrain to more than one object at once, since we're talking about weight. Let's create another object. Let's do a cube. And I'll name this box. double click. Enter. So in the same way that I applied the aim to the sphere, I'm going to apply it to the box as well. So now, if I look over here, you see I have ball weight is 1 and box weight is 1. I go back to my attributes here. Another place to find the weight values actually is down at the bottom of the attribute editor for the aim constraint, down under extra attributes. If you open this, you'll now see ball weight and box weight here. So you can also change those weight values here in the attribute editor. So right now they're both set to 1, meaning they're both fully active. So what's happening is when I move the two objects, the aim constraint is trying to kind of look at them both at the same time, which is failing miserably right now. Oh, my aim vector is X. Let's do this. There we go. So what it's doing now is it's looking between the two. I forgot I had when I applied the aim to the box, I had the default values, meaning that the aim vector went back to a positive X as opposed to a negative Z. So it had flipped my aim vector around. So now my aim vector has been fixed -1 in the Z-axis. So now the camera is looking at both of the objects because it is constrained to both of them. But because it's constrained to both of them, it's looking at a midpoint between the two. If I select my camera and turn on the show manipulator, this is showing you the camera manipulator, not the aim constraint. And it just gives you this line here indicating where the camera is looking. And it's looking at a point between the two constrained objects because it's constrained to both of them equally. So if I change my weight values to prefer one object over another one, you could say, for example, the ball is 0.5. You'll see how the aim shifts closer to the box. It's not looking at the box, but it's closer to the box. Think of it like a percentage. If there's 100% weight, you're applying half of that to the sphere and half of that to the cube when they're both set to 1. If you want one of them to be preferred, one thing that makes it easier in my head is instead of having one of them being 1 and another one being 0.5, I'll actually try to maintain that 100% ratio. So the ball would be 0.25 and the box would be 0.75. So it would still have that weighted value toward the box but not looking at the box. Because between the two values it equals 100%, one full value. So you can change the weight values and indicate which object you want the camera to kind of prefer, or you can turn one of them completely off and have the other one be 1 and it looks at that object, and then you can animate these values so that the ball becomes 1 and the box becomes 0 and it looks at that object. So you can kind of change the target based on the weight values. So that's being constrained to two objects at the same time. I think that's all of the attributes. I think we've talked about all of these. Let's go back to the constrain aim options. And the main ones we haven't talked about yet is maintain offset. And what that simply means is that whenever you create the aim to begin with, if the camera was looking away from the sphere and you said maintain that offset, if you check that and then apply the constraint, even if the aim vector is -1 in the z-axis and is correct, it will maintain the offset from the sphere that it originally had when you created the constraint. Let's just demonstrate that really quick. Let's just delete the box. So now the sphere is the target. But I want to reapply the constraints. I'm going to remove this constraint now and apply a new one. So if I select the sphere, shift select the camera, constrain, remove target. That's another command here. Remove target just removes the constraint. No longer has any effect. It's no longer even there. So again, I'm going to select the objects in the correct order. So aim vector, we want that to be -1 in the z-axis. We know that much based on what we've done already. I'm going to rotate the camera, let me move this, so that it's, whoops, I want to rotate the sphere. Rotate the camera so that it's kind of looking over here. But kind of looking above the sphere, like up here. So say maintain offset and hit apply. First select in the right order and then hit apply. So now that offset is still active. It's not looking at the object's pivot point anymore. It's looking above the object because it was looking at that point when you made the constraint. And so when you said maintain offset, maintain that positioning, it will then maintain that offset whenever you move the sphere. I hope that makes sense. And the rest of these I'm pretty sure we've gone over already, except for animation layers. We're going to have a video going over animation layers in the future, and we'll talk more about that. So when you come back to this video later, you'll know what all this is. And then constraint axes by default is all. So you're constraining on all 3 axes. You'll see that when I select my camera, rotate X, Y, and Z are all highlighted in blue. You can say only constrain in the Y axis, for example. So let me undo the constraint. There we go. And so maintain the constraint in the Y axis only. And hit apply. So now only my Y axis is highlighted blue. And last, we have node state down here. By default is normal, which means everything's working the way you expect it to. Let's go to display, UI elements, and command line. So then if we say node state has no effect, you'll see we get a warning. Let's open this up. It says warning, camera constraint has no effect, not supported on this constraint. So switching to blocked. So this node state attribute is actually a common attribute for lots of different things in Maya, and they don't change this list just because you're using an aim constraint. This list is the same regardless of what kind of node state property you're dealing with. So it has no effect. That node state does not apply to an aim constraint. So that's essentially what this is saying. Has no effect. It's not supported on aim constraints. So it's switching to blocking, which blocking is essentially the same thing, where it prevents Maya from applying the constraint. It essentially turns it off. Then you have waiting. Waiting normal. Waiting has no effect, which again would not be applied to an aim constraint. And then waiting blocking. What that means is it's based on your system performance preferences. If you have a kind of lower end machine, sometimes trying to update the scene every frame as you're moving the object around can be hardware intensive. And so what that allows you to do with the waiting is that it will wait until you finish moving the sphere, and when you let go of the mouse button with waiting normal, then the constraint will switch over to the sphere's position, as opposed to always aiming at the sphere while you're moving it. It just makes it a little less hardware intense. Same thing for these other two. Waiting, blocking. Waiting has no effect. It will wait for the effect, wait for you to do something, let go of the mouse, and then it will apply the visual, just for performance purposes. Most of the time, I don't worry about these 3. It's normally just leave it on normal and turn it off using wait values, is what I usually do. If I don't want the constraint to be active anymore, I'll just animate the wait down to 0. And it does kind of the same thing. Alright, well that's been aim constraints in a nutshell. If you noticed I missed something, definitely let me know. I want to make sure I get all this information to you. I hope you enjoyed the video and you learned a little bit. Thanks for watching, and please subscribe, comment, like. It's all really appreciated. And if you have any requests for future videos, let me know. Thanks a lot, guys.